In this video for section 5.5, we're going to look at joint probability and contingency tables. So we have an example here of a pick your prize promotion where a store is inviting customers to choose which of 3 prizes they'd like to win. And the choices are MP3, camera, and bike. And they also recorded for each respondent whether they were a man or a woman. And the results are in this table. This is called the contingency table. We saw these back in section 2.3. And so now we're going to use the contingency table to calculate probabilities of certain events. So the first type of probability we're going to look at is called marginal probability. And we talked before about the marginal distribution, which referred to the row and column totals. The marginal probability refers to a probability calculated using row and column totals. So for example, what is the probability that a respondent chosen at random is a woman? So what I need to think about is I need to find the total number of women that responded and divide that by the total number of respondents. So looking at the table, I can see that the total number of women that responded is 251, and the total number of respondents was 478. So it would be 251 divided by 478, which is approximately 0.525. Now again, you want to pay attention to how MyStatLab wants you to enter answers for these. They generally want you to enter the decimal instead of the fraction, and they usually want you to round to a specific number of digits after the decimal point. In this case, I'm rounding to 3 decimal places. So another type of probability that we can calculate is the joint probability, which gives the probability of 2 events occurring together. And often in the question, you will see the word and. So it's the probability of something and something else happening. This question doesn't specifically use the word and, but we can kind of interpret it to mean that. It says, what is the probability that a respondent chosen at random is a woman who wants a camera? So another way that I could say that is that what is the probability that a respondent is a woman and wants a camera? Instead of using the word who. So that's the same question. And to figure that out, I would look at my table and find the total number of respondents who were women and wanted a camera. In this case, that was 91. So there were 91 respondents who were women who wanted a camera, and we would divide that by the total number of respondents, which is still 478. And when I divide those two, I get approximately 0.190.